In the basement of the British Museum sits a clay tablet so small you could hide it in your palm. It is fragmentary, brown with age, the edges crumbled. Its catalog number is V.A.T. 11842, transferred on long-term loan from Berlin's Vorderasiatisches Museum to a vault that few visitors ever request to see. The tablet is older than Rome. It is older than the Acropolis. It was first inscribed during the late Babylonian period, sometime after 350 before the Common Era, and carved into its surface, in tiny cuneiform wedges, is a description of the god the Sumerians called Sag-me-gar, Jupiter. The text names something else. 4 small lights, the original calls them, 4 attendants who travel beside the great star and never leave his side. 4. The exact number Galileo would discover with his telescope nearly 2,000 years later in the winter of 1610. The tablet describes them. It names their pattern. It records their return. Before we open this codex, take a moment to subscribe to Origin Codex. This is where the original texts get translated, the books written before the books. If you stay until the end, I will show you what the establishment quietly archived in 2021, and the scholar who tried to publish it, and what happened next. The tablet was acquired by the Vorderasiatisches Museum in Berlin in the 1890s, as part of a larger consignment of fragments from the German excavations at Babylon led by Robert Koldewey. It was logged, photographed in the old plate glass style, and shelved. It carried the inventory mark V.A.T. 11842 and a brief notation in German that read, "Planetary observation, Seleucid era, untranslatable." The fragment sat undisturbed for nearly 120 years. In 2017, a research fellow at Heidelberg University named Dr. Henrik Vosberg requested the photograph as part of a survey of late Babylonian Jupiter procedure texts. He noticed something his predecessors had not. The fragment was not a procedure text. It was an observation report. It described what the scribe had seen in the sky on a specific night. And what the scribe had seen, according to Vosberg's transliteration, was Sag-me-gar, accompanied by 4 small fires arranged in a line. To understand why this matters, you have to understand who the Babylonian astronomers were. They were not stargazers in the modern sense. They were record keepers, working in a continuous, unbroken tradition that stretched back to Sumer. Their tools were the naked eye, a clear sightline to the horizon, and an obsessive willingness to write everything down. For nearly 700 years, from at least the 7th century before the Common Era to the 1st, scribes in Babylon kept what we now call the astronomical diaries, recording the position of every planet, the phase of the moon, the weather, the river levels, and the price of grain, night after night, in tablet after tablet. Their mathematical foundation was base 60. From it, we still inherit our 60 seconds, our 60 minutes, our 360 degrees of a circle. They tracked Jupiter, which they called Sag-me-gar in their logograms, and Marduk in their religious texts, and Mul-babar, the white star, in older Sumerian sources. They knew its 12-year cycle around the zodiac. They knew its stations, its retrograde loops, its heliacal risings. They had reduced Jupiter to a moving point of light whose every motion was predictable, until V.A.T. 11842 suggested something else was moving with it. The fragment is short, perhaps 23 lines, of which only 15 are legible. The dating formula at the top places the observation in the early Seleucid period, during the reign of one of the Antiochid kings, though the regnal year is broken. The opening lines describe the rising of Sag-me-gar at dusk above the temple of Esagila in Babylon. Then the unusual passage begins. Vosberg's working translation, which has never been formally published, reads as follows. When Sag-me-gar stood in the constellation of the Crab, and the night was clear without cloud, and the moon was absent, the watcher saw beside the great star 4 small fires. They did not depart from him. They moved as he moved. The first kept close to his side. The second stood at a small distance. the third farther still, the fourth at the greatest distance, and faint as the dimmest of the dim. The watcher recorded them on the evening of the 15th and again on the evening of the 17th, and their order had changed. The first had become the third had become the first. They do not wander as the planets wander, they circle him. The text closes with an omen formula, the kind that appears in the Enuma Anu Enlil series. When the great star is followed by his children, the king should give thanks, for the heart of Marduk is full. The phrase, his children, is what stopped Vosburgh cold, because the Babylonian word for what we translate as small fires in this specific tablet is the same word used for the satellites of a king, the attendants of his court. The scribe was not describing stars, he was describing companions. 4 of them, always 4, always beside Sag-me-gar. Recorded centuries before any human being looked at Jupiter through a lens, in 1610, in Padua, Italy, Galileo Galilei pointed a small homemade telescope at Jupiter for the first time. The instrument magnified 21 times, and the night of January 7th, he saw 3 small bright objects near the planet. On the night of January 13th, he saw 4. By the following week, he understood that these objects were not stars in the background. They were orbiting Jupiter. He named them the Medicean stars to flatter his Florentine patron. We know them today by the names Simon Marius gave them in 1614 at the suggestion of Johannes Kepler: Io, Europa, Ganymede, Callisto. Their apparent magnitudes range from 4.6 to 5.6. That number matters. The faintest object a sharp human eye can resolve under perfect dark skies is approximately magnitude 6, which means 3 of the 4 Galilean moons are theoretically within the reach of the naked eye. The reason no one sees them today is that Jupiter is roughly 1,000 times brighter than they are, and its glare drowns them out. But the moons are real, and the light from them reaches your retina even now if you stare at Jupiter on a clear night. You simply cannot resolve them. In 2016, Dr. Matthew Ossendriver, then at Humboldt University Berlin, published a paper in the journal Science showing that Babylonian astronomers in this same Seleucid period had been calculating Jupiter's position using the area under a velocity time graph, a method credited until then to 14th century Oxford. The Babylonians, it turned out, had been performing the work of integral calculus 1,400 years before Newton. Babylon was not alone. In the year 364 before the Common Era, a Chinese astronomer named Gan De recorded a small reddish star attached to the side of Jupiter. The note survived because it was preserved in an 8th century Tang Dynasty astronomical encyclopedia called the Kaiyuan Zhanjing. In 1981, the Chinese historian of science Shi Zezong published a paper in Acta Astrophysica Sinica, arguing that Gan De had glimpsed Ganymede or Callisto with the naked eye nearly 2,000 years before Galileo. Shi Zezong's identification is debated, but the text exists, the phrase exists. Gan De saw something, appended to Jupiter. He wrote it down. The Babylonian fragment V.A.T. 11842 records 4 somethings beside Sag-me-gar. 2 civilizations on 2 continents, separated by deserts and oceans and 1,000 years of silence, both report the same kind of thing on the same kind of night. Both are dismissed. Neither has been adequately explained. There is a real scientific basis for considering this possible. The night sky over southern Mesopotamia in the first millennium before the Common Era was a sky no living person has ever seen. No streetlights, no power grids, no haze of carbon. The dry desert air over the Euphrates produced what astronomers call a magnitude 6.5 limit, meaning the human eye could resolve objects nearly twice as faint as anything visible from a modern city. Babylonian observers stood on the flat tops of ziggurats, hundreds of feet above the plain. They had ideal sight lines. They watched the same patch of sky every night for generations. And if you stare at Jupiter long enough with a tree branch or a temple wall blocking its disk, the surrounding points of light become resolvable. Modern observers have reported glimpsing the Galilean moons by this exact method. The data tells a different story than the textbooks. Dr. Henrik Vosburg drafted his findings in 2019. The paper was titled, "A Possible Naked Eye Observation of the Galilean Satellites in a Late Babylonian Fragment." It was submitted to the journal Archive for History of Exact Sciences. It was returned without peer review, with a brief note from the editor stating that the interpretation was inconsistent with established consensus on Babylonian observational capacity. Vosburg revised the paper and submitted it elsewhere. It was returned again. In 2021, Vosburg's funding at Heidelberg was not renewed. His departmental page was taken down. The Vorderasiatisches Museum, when asked by a journalist for a German weekly, confirmed only that V.A.T. 11842 existed in the collection and was not currently available for study. Requests for a high-resolution photograph went unanswered. Vosburg has not published since. According to colleagues who have spoken anonymously, he is now teaching at a gymnasium in Lower Saxony and does not respond to emails about the tablet. The fragment, however, still exists. It still says what it says. Now let me address the wild interpretation directly. The wild interpretation is that the Babylonians had a telescope, or some inherited memory of pre-flood astronomy that allowed them to see what the rest of the ancient world could not. Almost certainly not. There is no archaeological evidence of optical lenses in Mesopotamia capable of resolving moons 2 arc minutes from a planet's disk. The famous Nimrod lens, often cited as a Babylonian telescope, is far too crude to be one. But that does not mean the fragment is fiction. There is a milder explanation, and it is far more interesting. A single observer, on a single rare night, under perfect conditions, with eyes adapted by hours of darkness, may have glimpsed what was almost always invisible. He wrote it down. The scribe who copied his record did not know what it meant. He filed it under planetary omens and moved on. The observation survived, accidentally, in a fragment that nobody looked at carefully for 23 centuries. There are roughly 130,000 cuneiform tablets in the British Museum alone. The vast majority have never been translated. They sit in drawers, in racks, in the basement archive on Great Russell Street, untouched. In 2023, the Ludwig Maximilians University in Munich launched a project called the Fragmentarium, led by Dr. Enrique Jimenez, which uses artificial intelligence to identify and join fragments that human eyes have missed. The system has already produced more than 1,200 new joins. New texts are surfacing every month. The Epic of Gilgamesh now has lines it did not have last year. The question is no longer whether the ancient world recorded things we did not know they could record. The question is, what else is still buried in those drawers, waiting for a machine to notice it? The fragment sits in Berlin tonight, in a temperature-controlled drawer, in the Vorderasiatisches Museum. You can request to view it. Most people do not. The text is older than the language it was written in. The watcher who saw the 4 small fires beside Sag-me-gar is 23 centuries dead. His name is gone. His city is rubble. But the clay survived. The wedges he pressed into it survived. And the 4 small fires he counted are still there tonight, beside Jupiter, exactly where he said they would be. If you want more breakdowns of the original texts the establishment does not translate, subscribe to Origin Codex now. Next week, I am covering the Sumerian cylinder seal that shows 12 planets, including 3 that do not exist anymore.